Hello everyone and welcome to the second part of physical quantities and measurement. In earlier part of the video we have studied about density, relative density, and now in this part we will be studying about the flotation, the principles of flotation. So let's start. In our daily activity we have noticed that some objects sink in water whereas some objects float in water. Why is it so? For example, we have got a metal coin here. If you put it in water, in a glass of water, you will see that it sinks down. But if you take a ball, for example, we have got a ball made of thermocol ball. So we will see that it floats on the surface of water. Why is it so? It is due to the difference in densities between the coin objects and the water, or to say it specifically, the fluid in which it is suspended. Not necessarily only water is the fluid. For example, here if the example is water, then the density of iron or steel, whatever object it is, material it is made with, the coin is greater than density of water. But in this case, density of thermocol is less than density of water. This is the reason why it floats. Okay. We will discuss about this, the reason why this density affects the flotation, in the next part. Here in this chart we have got some examples. For example, water at 4 degrees centigrade. Now it should be mentioned that water exhibits a anomalous behavior, right? Means it's a exceptional substance. Water has got the most thickness, the greatest density at 4 degrees centigrade. Whenever we heat water from 4 degrees centigrade, the density decreases, and as we cool down water, for example, at 3 degrees centigrade, the density of water will be less than the density of water at 4 degrees centigrade. Okay. That is why ice has lesser density than water. In at the home, if you take a glass of water and put some ice on it, you will see that it floats like this. Even if you push it with your finger to sink it down, you will see that it again comes up to the surface. This is the reason why. Why does it happen? Because the density of ice is less than that of water. Cork, see, air has so less density, it's so thin. That is why most of the objects we see are if, sits on the surface of the earth or on the table like that. It does not go up. If you take a gas balloon, hydrogen balloon, then it will rise up in the air, because that gas balloon has a density, the average density is less than 0.0012. Cork, see, if you put a piece of cork on water, it will float, it won't sink down. That because why? See, the cork has a density of 0.24 as compared to water. You take all the examples, iron, aluminium, gold, these are all metals. So if you put it in water, it will sink because they have density or relative density more than water. But see ice, it's 0.92, that is why it floats on water. So the thumb rule is, if anything, any material which has got density less than, for example, density of a material M is greater than the density of fluid F. I am taking in general, not only water, any fluid. So the M will sink in F. And if the reverse is true, if the density of M is less than the density of F, then M will float in F. Let's move on. Now let us have a quick knowledge of buoyancy. What is buoyancy? Buoyancy is the upthrust that is provided. Buoyancy is the reason due to which any object, whether it's heavier than water or lighter than water, less dense than water, whether it floats, whether it sinks completely, anything, it loses its weight. There is a decrease in weight. How will you measure it? If you take a spring balance, it's very easy to measure. If you take a spring balance and there is a hook here and you suspend this item like this. For example, it shows it's 5 kg. Now this is the mass which is showing. There is a difference between mass and weight. So it's the mass which is showing 5 kg. If I convert to, so what is the weight? So we will be, now let's make clear, we will be concerned about the weight and not mass, because mass does not change, weight changes. There can be a decrease or increase in weight, but there cannot be any change in mass. So if the measurement here is given 5 kg, what is the force? What is the weight? Let's convert it to weight. Weight is equal to 5 kg force. Means we have to multiply it with 5 kg into 9.8, which is equal to 49 Newton. Okay, from 5 kgf to Newton, we convert it to Newton. Now we put the whole thing inside water so that it's immersed. Not the whole thing, means only the object, and keeping it suspended in the spring balance like this only. We will see, if we put the thing in water, we will see that the weight, the reading reduces. For example, let it be 4 kg. Now it's showing 4 kg. Now if I again convert it to weight, so it's 4 kg force is equal to 4 into 9.8 Newton, 39.2 Newton. Okay, you can keep it in kgf or you can keep it in Newton. See, there is a decrease in weight, decrease in force from 5 kg force to 4 kg force, or from 4 to 49.0 Newton to 39.0 Newton. So what is the difference? So difference is 1 kg force or 9.8 Newton, whatever you tell it. So this is the upthrust that is provided by the fluid to this body, right? Whether it sinks or it floats, irrespective of that, every body experiences a upthrust. And what is the upthrust? The upthrust is provided by the displaced liquid. This is very important aspect. Why? From where does this upthrust come? Let's see here. From where does this upthrust come? This upthrust comes because of the displaced liquid. Let's do a small experiment here. We take a glass filled up with water to up to the brim, means adding one more drop of water, one drop of that drop will spill out. It's just in a equilibrium condition. Now we keep the whole glass on a tub like this, on a empty dry tub, so that we can collect the spilled water. Now we put this object, it may be a regular body, anything, whatever, in the water. We will see that some water spills out. Some water spills out. If we measure the weight of this water, for example, again I am telling, we will measure the weight, not the mass, right? If we measure the weight of this water, that water that has spilled out, for example, the water spilled out is, for example, 1 kg force is equal to or 9.8 Newton, whatever. The weight of the water which is spilled out. Now, if we do the same experiment that I have mentioned in the previous slide, doing that experiment with the spring balance, we will see that there is a reduction of 1 kg force or 9.8 Newton in the reading. Got it? This will happen mandatorily. For example, again, if the stone, initial weight of the stone outside water was 5 Newton, 5 kg force, and if the weight of the water that has spilled out is 1 kg force, then the reading inside water will be 4 kg force. If the weight of water is 2 kg force, then or rather in a reverse way, if instead of 5 kg, 4 kg, the reading is 3 kg force, then if we again, so the reduction is weight in 2 kg force. Reduction, let's keep it in kg force only for just simplicity. To convert from kg force to Newton, we have to just multiply with 9.8. Right? You must all know this thing. Now, if the reduction in weight is 2 kg force, then if we measure the weight of the water, we will see that the weight of the water is 2 kg force. So the thumb rule or the rule is that the weight of the displaced liquid is equal to the upthrust or the buoyant force. So let's write it here. Weight of displaced liquid is equal to buoyant force or upthrust, which is equal to reduction in weight of object, right? Now let us move on to principle of flotation. Now up to this, if you have any doubts or anything, you please comment me and I will explain it in the comment itself. Now let us study about the principle of flotation. Now what happens, I should mention here, what happens in case of a floating body. The body does not sink. For example, in this case we of wood. This is a log of wood. We put in water. It will float, right? It won't sink. But still, even if the weight of this object is very less, but it has got a minimum weight, of course. Means any object cannot be, the weight cannot be zero, right? It will have a minimum weight, so it will spill out or it will displace. Even if it does not spills out like this, it will displace some amount of liquid. That weight of liquid will be equal to the upthrust, right? Even if it floats on water, it need not sink down. So let's study the, so there can be three cases. First case can be like, there can be three cases. In one case, if I put the body, it will sink. Like if I put a coin or a bar of metal in water, it will sink down. In the second case, it may be that the body floats above the surface of water, and in another case, it will float just so that the upper surface of the body is just in touch with the surface of water. So let's study the cases one by one. So in the first case, let us study about the body which sinks in water, right? In this case, the upthrust, for example, the weight, in this case, the weight of the body is greater than the upthrust, right? When this condition is satisfied, weight of the body is greater than the upthrust provided by the displaced liquid, then in this case the body will sink. So let us do this with a simple example. For the weight of the body, let us assume the weight, the initial weight, you will do the same experiment with the spring balance. With the weight of the body before or outside the water is, let's take its, again for simplicity, let's take its 10 kgf, and after putting in water before, right, let us write before, and after putting in water, we see that it's the reduced to 8 kg force. We measure it with a spring balance totally. So what is the reduction? Reduction is equal to 10 minus 8 is equal to 2 kg force. This reduction in weight is the upthrust. Upthrust. What is the upthrust? This is 2 kg force. Now see, this weight W is greater than upthrust, which is 2 kg. Of course, 10 kg will be greater than 2 kg. In this case, the body will sink. Now what happens? What is happening? We have studied about equilibrium, right? So the weight of the body acts like this. Weight of the body acts like this. For example, now let us take the body here, because the body is here, let's assume, and the water or the fluid gives a upthrust like Fb. Let us denote by force, buoyant force Fb. If so, what is the net force on this body and in which direction? If W is greater than Fb, so the net force will be W minus Fb, the net force. And since W minus Fb, or the net force, is greater than Fb, the body will sink down because the direction of the net force is downwards. It's simple. The equilibrium of bodies and everything, all the concepts. What we have, just if we apply the numerical things, if the W is equal to 10 kg F and Fb is equal to, the buoyant force is 2 kg F, we have found it here, the buoyant force is 2 kg F. So the net force will be how much? 8 kg F, and which is in the downward direction. And since 8 is greater than 2, it will sink down. The weight of the body will be riding against, means will be greater, will be winning against the F buoyant force, so it will sink down. Okay. Now let us study about the second case where the body floats. See, it's a very light object. For example, a thermocol ball, or you can, that squeezy ball, that we get, we we can press those balls, that squeezy ball, right? If we put it on the water, we will see that it floats. But keep in mind that the ball has got a minimum weight. Its density is less than water and everything, but it has got a minimum weight. For example, let's assume weight is equal to 1 kg only, 1 kg force. Now, if I put this in water, it will displace some amount of liquid, very minimum amount of liquid, because since it's very light, but still since it has got some weight, it will go inside the water a bit, and the amount of water is equal to the amount of water displaced is equal to the amount of substance of object, amount of the volume of the object which has got inside, which is inside the water. The volume of water which is displaced will be equal to the volume of the object which is inside the water. Now let us take the, if I measure the of volume, if I measure the weight of the water that is displaced, we will see that the weight of water is equal to 1 kgf. This is the thing. Now, in this case, the weight of the water and the buoyant force Fb will be in equilibrium. That is, W is equal to Fb. The weight of the object will be equal to the buoyant force. And that is the reason why the object will float on water. Now, if we do a simple experiment, if we forcefully put the ball inside, right? If you take a plastic ball, plastic cricket ball, or a football, if you take a football, it will be better to understand because the force will be more. If you forcefully put in water with your hand, you will see that the ball tries to rise up. Why? Because in this case the water displaced will be more, right? In the earlier case the water displaced was only due to this volume, but here when you put it forcefully inside, the volume will be more, the volume of water displaced. So the buoyant force will be more, and the buoyant force will be greater than the W of the weight of the ball. So it will give a force upwards. Our hand will feel a force, and if we release it, the ball will come to a, this is important, will come to this a certain equilibrium position where the volume displaced by the ball, the volume of water displaced by the ball weight will be just equal to the weight of the ball, and they will balance each other. Now in the equilibrium condition, one thing, in the equilibrium condition, when there is no external force, we are not applying an external force, if B cannot be greater than W, because in that case the ball will rise up, right? That cannot happen. So an equilibrium position will come such that the total system will do it automatically, that if W of the ball becomes equal to Fb, and in this case the body will float partially. Now in the third case, body sinks partially. That is the thing that we have already discussed actually. For example, this is a wooden block and it floats with this much above the surface of water, this much part, and this much part is below the surface of water, for example. So the buoyant force or the weight, the W of the body, will balance the buoyant force Fb, which is given by the amount of liquid which is displaced by this portion, this sinking portion. The portion of the water which is sinking below the surface of water, only this portion, the water displaced by this portion of water object will be balancing this W. In this case also W. is equal to the buoyant force. So these are the three cases of flotation. In the first case, W will be greater than Fb when the body sinks, and in the two cases W will be is equal to Fb when the body partially or completely floats on the surface, right? These are the means the two and the third case are almost the same. These are the conditions for flotation. So what can be the conclusion of the principle of flotation? Just the same thing that we have studied. Again I am telling, when W or weight of the object, weight means force, again, is greater than the upthrust or buoyant force, then the body will sink. If W is equal to the upthrust or buoyant force, the body will float. These are the conditions, right? Now this flotation, this principle of flotation is applicable in many of phenomena in our life. Like a ship floats on water, a hot air balloon rises, right? So let's discuss three things. There are lots of things that happens due to flotation, but just these are the common phenomena. A ship floats on water. See, a ship is made of iron, right? But still it floats on water. But if you put a nail, a simple nail on water, it, or a coin that is also made of metal, but that thing sinks down. Why? Because a ship is made like a what? Like this, no? Just a crude drawing. Or if you take a that utensil, a katora, a bowl, and put it on water, it will see that it floats. Because if I take the total volume including the empty space, because there is empty space out here in a ship, just see, in a ship the total inside it's empty, it's filled with air, right? It's inside is air. So if I take the total volume and the mass, if I calculate, right, if I take the total weight of this ship, that will be enormous. But let take an example just for the sake of calculation, that would be some millions of tons, okay. But just for an example, let's take the weight of the ship is 10 kg, 10 kgf, and the volume is, weight is equal to 10 kgf, and volume is equal to, in this case the volume is more because it also contains the air inside. We have to take the whole volume. The volume is, for example, now instead of kg force we take it to be, for example, weight is gram, only gram. Take the weight to be gram instead, for simplicity. weight is equal to 10 gram. And the volume is, for example, 20 cc, centimeter cube. Now what will be the density? Now it's not weight, let's take it to be mass. Mass is equal to 10 gram. So what will be the density? D is equal to mass by volume. So it will be 10 divided by 20 is equal to 0.5 grams per cc, which is less than 1. So it will float on water. Now if I crumble the entire thing to a small ball of iron, so it will become like this. If I crush the whole thing, like it will become like this, so volume will decrease drastically. Now if I measure the volume, it will be like, for example, 2 cc, 2 centimeter cube. Now in this case, if I again measure the density, let's take it as d1, and if I take it d2, it will see that it's 10 grams by 2 cc is equal to 5 grams per cc, which is, sorry, it should be less than 1, which is greater than 1, right? So in this case it will sink. So we can just apply the reason that a ship, the average density, if we consider the total volume of the ship, the average density is less than the density of water. Is this reason why a ship. Now in the second case, second application, we can take a hot air balloon rises. You have seen, everyone, no? A hot air balloon rises in air. In this case, the fluid is what? Air. Earlier it was water. In this case, the fluid is air. Now we all know that when air or anything which is heated, the density decreases. Now whenever we heat, we apply fire from below, and the air inside this balloon is hot, and when it is hot, the density is low, density decreases. Now if I take the density of the total balloon, if I take, again if we measure, if I take the mass of the balloon and the volume of the balloon, if we calculate the density of the entire system, we will see that density or average density of balloon will be less than density of air. That is why it rises. Now if we cool down the air, you will find that the average density of the balloon will be greater than the density of air, so it won't go up. That is another aspect. We can see that it is easier for us to swim in sea than in pool. Why? Here our mass remains same. Whenever we swim, where our density remains the same, but seawater, the density of seawater is greater than the density of pool pool water, the density of the water which is inside the swimming pool. And so the difference in density between us and the seawater will be less than the difference of the density between us and the pool. So it will be, so upthrust generated here will be more in case of seawater than the upthrust generated when we swim at the pool. And that is why it will be easier for us to swim in seawater. One fun fact is that if we can float on Dead Sea. Dead Sea. It's a lake, it's an inland sea which has got so much salt in it that the density is has become more than the density of us, of human beings. So we can float on this inland sea, we won't get drowned, right? And just let us discuss why the density is more, because of the suspended solid which is salt, because seawater is salty, right? And whenever there is that solid in it, the density increases. But in pool water there is no such salt or or mixed substances in it which can increase the density. So that is the reason for flotation. So that's all in this video. If you have any doubt, please ask me, and please subscribe, keep me motivated. You can do this bit of thing. Okay, bye for now. We will meet again in the next video.